Hi, in the final video of our series, we will cover the step-by-step troubleshooting procedures for drones. In this context, we will address the following components of drones: the frame, fuselage, landing gear for physical image, the battery and power distribution board for power system, motors, propellers and electronic speed controller for the propulsion system, sensors such as flight control board, IMU and GPS, the remote control receivers telemetry system for control and communication system, the gimbal and camera system for payloads, and the firmware for product software. To troubleshoot the drone by physical inspection, carefully examine the drone visually to identify any possible damage. First, check for cracks, dents or broken parts of fuselage or frame and landing gear. Then inspect the propellers, motors, electronic speed controllers for loose screw wires and connectors. Assess the extent of damage. If it is minor, decide whether it can be repaired. If there is significant damage, replacement parts should be used. For minor damage, first clean the damaged area, then apply adhesives. After the adhesive dries, sand the surface to smooth it out. For major damage, replace the broken or damaged part. Finally, conduct a flight test to confirm that structural issue has been resolved. Observe the drone stability and check for any vibration or resonance issue. To troubleshoot the battery and power distribution board, check that the battery connections are properly made and ensure that the charger is correctly connected to the battery. Inspect the connection pins for any damage or dirt to prevent connection issues. Additionally, test the charger with a different power source to verify that it is working correctly and compatible with the battery. After confirming that the power inputs are functioning correctly, check the overall condition of battery and number of charge cycles using a drone application or a multimeter. Inspect the battery for any physical damage and ensure it fits securely and properly in drone slot for safe use. Check if drone has latest firmware updates, as outdated firmware can sometimes cause charging issues. Regularly monitor the battery charge level to understand unexpected power loss during flight. Use a battery within the optimal temperature range, as the extreme hot and cold weather condition can negatively affect the battery performance. Review the drone's flight logs to identify potential battery issues and reset the drone to factory settings to resolve any possible voltage readings errors related to firmware. To troubleshoot power distribution board, first check the burnt, cracked or broken solder joints. Inspect the cold solder or loose connection to prevent connection errors. Measure the input and output voltage with a multimeter and compare them with the expected values. Check if the overcurrent or short circuit protection circuits are active and test the fuses for integrity. Perform fault checks on basic components such as MOSFET, diodes, capacitors, and resistors, and measure for short circuits in the power connection of board using a measuring instrument. If the board is determined to be faulty after all tests, replace it with a new distribution board, if repair not possible. To troubleshoot propulsion system in another motors, propellers and ESCs, first carefully inspect the motor for visible damage, burn marks or any residue. Smell the motor to detect any burnt odor or look for signs of overheating. Ensure all connections are secure by inspecting loose or damaged wires. Measure the internal resistance value of motor using a multimeter and evaluate the compatibility of ESC and battery with the motor. Also ensure the drone receives adequate airflows and avoid flying extremely in hot conditions. If the motor is damaged or constantly overheating, it should be replaced. To troubleshoot propellers, first check that propellers are installed in the correct direction. Ensure the mounting is securely by tightening any loose screws or bolts and check the alignment. Carefully inspect the propeller for cracks, breaks, deformation and clip them up to improve the performance. Use a proper balance device to check if the propellers are balanced. If the propellers are damaged or unbalanced, replace them with the same model to maintain consistency. To troubleshoot the ESC, first check the physical damage, burn marks or loose connection. Verify that there is no burnt odor from the ESC and check signs for overheating. Measure the voltage coming from ESC to ensure it is sufficient. If cold solder or looseness is detected in connection, correct it with the soldering. Finally, check the integrity of the PWM, PPM or D-shot connections between the flight controller boards and ESC. If the ESC is damaged, constantly overheated, it should be replaced. To troubleshoot flight controller board and sensors, first physically inspect the flight controller board for any burn marks, cracks or loose connections. Ensure the board is properly mounted and secured. Test the integrity of solder joints at the connection point. Measure the power inputs and regulator output of the board using a multimeter to check appropriate voltage levels. Check if the flight control board's firmware is up to date and update it if necessary. Ensure the connection of sensors such as IMU, GPS, barometer, etc. are correct and tight. Perform calibration procedures to test the proper functioning of IMU and compass. Test the sensor in different environments to observe the environmental impact. Check if GPS module receives sufficient satellite connection in an open area. Check the error codes of board or sensor through the flight control firmware. If the sensors are not working properly, replace them with new ones. To troubleshoot remote controller, communication and telemetry issues in drone, first check the operating range of remote control and ensure you do not exceed the range limit of specified in UAV user manual. Inspect the antennas on UAV and remote control for physical damage and ensure the antennas are correctly positioned and not obscured by any obstacles. Verify that the UAV and remote control operate on the same frequency and detect any interference from nearby radio transmitters, Wi-Fi networks, or other electronic devices. Use a spectrum analyzer to identify the potential sources of interference and switch to a less congested frequency band. Prevent electromagnetic interference by using shielded cables and repositioning the antennas to minimize signal interruption. If there are compatibility issues between the UAV and ground control station, first verify firmware compatibility from the manufacturer documentation. Check the documentation settings to ensure the baud rate and protocol alignment are correctly configured. Test with an alternative ground control station to determine if the issue is hardware or software related. If the problem persists, record error message, collect flight log files and contact manufacturer support. Ensure that waypoints are correctly set, not overlap in mission planning. Verify that telemetry system is working correctly by ensuring the telemetry settings on UAV and remote control are properly configured. Confirm that data transmission is done at the correct bandwidth and frequency. Inspect the telemetry module for physical damage or loose connection. to ensure the module securely seated. Check if the UAV and remote control have the latest firmware version. Use the real-time monitoring tools to track anomalies in the system. To troubleshoot the gimbal and camera issues in UAV payload attachment, check the broken or cracked or loose connection. Ensure all parts move freely and carefully inspect for sticking, jamming, or abnormal vibrations. Ensure the camera and gimbal connection are secure, as loose connection directly affect image quality. Identify damaged or incorrectly installed cables and check the battery voltage and power supply. And ensure optimal performance by installing the latest firmware for the gimbal and camera. If issue persists, reset the gimbal and camera setting to factory defaults and recalibrate it. Examine image stability during the flight to identify the abnormal vibration. Test the correct operation of modes such as FPV or follow mode on gimbal and ensure the gimbal axes move freely are not obscured. Check for clarity, chromatic aberrations, focus issues. Test recording start, stop, and data transfer to ensure the memory card is correctly inserted and has sufficient space. Identify interruption in live video transmission and check that gimbal and camera components are not overheating. If all these solutions do not work, proceed with the part replacement. To troubleshoot firmware issues in UAV, first complete the turn off your drone and remote controller. Download the latest firmware from the manufacturer website and ensure the batteries your drone and remote control are sufficiently charged. Before updating, do not forget backup important data and settings. Run the downloaded firmware and follow the manufacturer instruction to start the firmware update process. Ensure you have an internet connection during the update process and do not turn off, disconnect your drone or remote control until the process is complete. After update process is complete, turn off your drone and remote control and ensure everything is working smoothly. If the issue persists, check the frequently asked questions section on manufacturer website or contact technical support. In the last video of our troubleshooting series, we touched on what to step by step in troubleshooting. I hope all contents were useful. Goodbye.